Hi and welcome to my channel. Today I'm going to talk about my favorite feature on the TEK 465 scope, which is the channel 1 vertical signal output. This output is very simple. It's just a BNC jack at the back of the device. But what it does is it takes whatever you put on the channel 1 input and it normalizes that signal down to 50 millivolts per division. So if you have a high voltage signal going into the scope, say you got 30 volts or something going into the scope, you can use this output in order to drive an external device like a frequency counter or another scope even, and have a normalized signal, something that you can guarantee within a certain voltage range. I've even used it to drive electronic circuits that were under test. I could apply a higher voltage input and just kind of use the scope as a bit of an attenuator in order to drive these other circuits. So it's a really handy thing. Most scopes nowadays don't really need this type of output because they'll have frequency counters built in. But for an older scope, if you compare the TEK products to the HP products, most of the HPs, in fact, I've never seen one with a similar output, they don't have this. Whereas the TEK scopes, they have this on a lot of their scopes, and it's a super handy feature. So I'm just going to show you how it works really quickly. Okay, so here's the back of the TEK 465 scope, and second from the bottom we have the channel 1 vertical signal out. It's 50 millivolts per division, and that's at 50 ohms. So on a 50 ohm load, you're going to get pretty close to exactly 50 millivolts per division. On something other than that, that voltage will vary, but it'll be consistent as long as your load is consistent. So all you need to do is take a BNC cable, plug it in there. Pro tip for you is always buy quality cables. These are Pomona cables. They're a brand name cable. I bought them used, and actually the used ones are better than a lot of the new ones that you'll buy in a store. Like if you buy a cheap cable from your local electronics store, as I've done in the past, they fall apart. They won't look like they're broken, but they will be, and you'll be trying to measure things and it just won't measure. So much frustration. I broke down, found some used ones online and bought these, and they're a really good investment. So my advice to you is buy quality cables. Anyways, we've got this connected up, and now we're going to test it out a bit. So I'm going to start by applying a 5,000 hertz signal. Let's do this, 50, 5,000 hertz at 1 volt to the scope channel 1 input. 1 volt. There you go. We can see we have a nice waveform. And then this is the output from the back of the scope. And I'm going to apply that to channel 2 so we can take a look. And if we take a look at channel 2, it's an attenuated version of that signal up there. So I'll go alt, we can look at them at the same time. You can see this one is a 1 volt peak to peak signal. This one is a 0.1 volt peak to peak on the output. So it's been attenuated within that range, which is great. You'll notice the shape of the waveform is different. Now if you're you know a lot about scopes and you've worked with electronics a lot, this will totally make sense to you, but it might not make sense if you're a newbie. The reason the shape is different is because the frequency is actually the same. So that on the time domain, basically it is the same amount of space between the peaks in the waveform. However, the amplitude is lower, so the shape of the waveform looks completely different. So just as an example, what I'll do is I'll crank up the voltage on the function generator up to 2 volts. And you'll see that the channel 1 input signal has gone, it extends to the whole height of the screen. And the channel 2 has also doubled in size, but it's, within one actual grid line. So right there and that one grid line is going to be half a volt between the two markers based on the settings. Where it gets more interesting is where I start to really crank the voltage up here on the signal generator. So I'm going to go and switch channel 1 down to say 2 volts a division, and then I'm going to set this to 10 volts peak to peak, and you can see that it is basically taking up the whole screen. I'll switch it down to say 5 volts per division, so you can see there's the input signal. You can see that the channel 2 signal is still within the 1 division there. What that means is I can actually use the signal to drive another device without overloading it. So just as a quick example, I'm going to use my counter, my quite retro counter, and I'm going to set the sensitivity to, let's say, plug in. This is millivolts, so 50 millivolts, probably 30 millivolts is going to be fine. Take a look, see if it works. Input here, and yeah, we're right centered as far as the level is concerned. And we let this count, and you can see that it is counting to exactly 5,000 hertz. This attenuation, I've got 10 volts being generated, going into my scope, being attenuated down to 50 millivolts per division, and going into my counter and not blowing it up, which is a handy feature. And in fact, generally speaking, I leave my counter connected up to my scope most of the time, so that gives me an extra feature on the scope that you know, I wouldn't normally have with a vintage 1972 oscilloscope. So I hope you liked that video. I hope that was informative to you, and subscribe if you want to see more videos about electronics, programming, and retro computing. Thanks a lot.